Okay, good morning. This is for physical science, and we are dealing with the gas laws. So just before I forget to remind you, the work that you received last week, last Thursday, is actually for 2 weeks. So I know that you've probably done maybe like 1/3 of it. That is not due till next Thursday, April the 23rd. So if anything is labeled gas laws or it deals with pressure, volume, temperature, or anything that is similar to that, that's actually not due till next week. So you're not picking up any work today. You're not necessarily dropping off anything today. All of this is due next Thursday, but you do need to pay attention. Also, I've already created lessons on videos for chemistry class that deal with gas laws. That is also kind of like a addition to this. You might want to watch those as well, just in case some of this might not fully make sense at the beginning, or sometimes you may not fully understand, or you need a reminder. Watch those as well. You gotta find those. Those are under the playlist for science classes, high school science. So if you locate those, some of those are labeled gas laws, and that will help you understand this a lot better. I'm gonna start from the beginning. What I need you to have out is a sheet of paper that says chemistry at the top, and it says gas laws worksheet. It's a pretty full sheet of paper, and it has a lot of formulas on it, and it has a lot of numbers and letters on it. At the top, it's gonna say Boyle's Law, Charles' Law, Gay-Lussac's Law, combined gas law. If you find all of those on one single sheet of paper, that's gonna be your best friend for the next couple of days. Make sure you have that sheet out so it makes sense what it is that I'm talking about. Once again, you want to have this sheet of paper. It's like at the beginning of a packet of several problems. That is your sheet that's going to have all of the formulas for the next couple of lessons. Always have that out when you're watching lessons on gas laws. So you're actually going to see at the top that you have 4 different gas laws. You have Boyle's, once again, you have Charles, Gay-Lussac's, and combined gas law. Those are all variations of each other. You're going to be working with 3 different compositions of the gas laws, which is P, V, and T. Pressure, volume, and temperature. Pressure, volume, and temperature. That's what that stands for. P is pressure, V is volume, T is temperature. You remember those 3? You're off to a great start. So those are the components of these 3 laws. Now, instead of me going through each one, first this is Boyle's Law, second this is Charles' Law, third this is Gay-Lussac's Law, and lastly this is the combined gas law, I'm going to teach you one of them and how that one is going to be able to be applied for the other 3. As I already mentioned, they're variations of each other, so this is a lot easier if you just understand the longer one. The easier, shorter ones will become a lot easier for you to comprehend. Now you'll also notice that some of these laws are written in a fraction form, and that is if you want to do proportions with it. And I don't advise that. I would just advise the one that is written out lengthwise. If you see the ones that are in fraction form, that is for proportions. Those are not incorrect. You can also use those. Those are just as correct as these. These are just easier to understand. It's just simple multiplication and division, and this is why I choose to teach with these. So once again, if you see that there's Boyle's Law and there's 2 different ones, and sometimes they'll have like a K constant, or sometimes they're written in a fraction form, don't let that intimidate you or freak you out. You just want to use the one that is written out lengthwise. So this is actually my combined gas law, combined gas law. So I want you to locate that little square that says combined gas law. It's at the top right of your sheet of paper, and this is it. Once again, you have P, V, and T. Pressure, volume, temperature. Pressure, volume, temperature. You'll notice that they have a subscript. They have a small number next to them, and there's 2 sides to your equal sign. You got pressure 1, that's P1. V1 is volume 1, T2 is temperature 2. On the other side, you got pressure 2, volume 2, temperature 1. This is a formula that I think eventually, within a couple of days, if not sooner, you're gonna already have it memorized. It's very easy to recognize and very easy to remember. You're just using 3 letters and 2 numbers, P, V, T, and 1 and 2. Now, I think a tip that I would give you is pressure and volume, 1 always comes first on that side, and pressure and volume 2 always comes first on this side, or 2 comes on this side. Then I want you to notice that temperature is the only one that's switched. You got temperature 2 on that side, temperature 1 on this side. All of your 1s for pressure and volume are on that side. All of your 2s for pressure and volume are on this side. And temperature is switched. T2 comes first, T1 comes second, T2 is on that side, T1 is on this side. Again, with practice, this becomes a lot easier for you. It's just a matter of recognizing that formula and using it over and over. So it's pressure 1, volume 1, temperature 2 equals pressure 2, volume 2, temperature 1. Have that memorized, have that written down, practice it over and over when applying it to your problems, and it does become a lot easier. Now, what you definitely need to get used to is your units. You know that in science class and probably in math class, units are very important. You would not understand these formulas, you would not understand the word problems at all if you don't recognize these units. Now, these units are written all throughout this piece of paper, but I want you to write these down. I want you to take a picture, a screenshot, or write them down, and please make sure you familiarize yourself with them. The one that has the most is pressure. That's the one we're going to focus on a little bit more. Volume and temperature are easily recognizable. You've actually worked with these units before. So let's look first at pressure. You're going to see ATM. That is for atmospheres. It's a unit of pressure. ATMs or atmospheres is a unit of pressure. Every time you see that, automatically assume that is pressure. Then you have kPa, which is an abbreviation for kilopascals, named after Blaise Pascal, which is a scientist that contributed to the study when it comes to atmospheric pressure. So once again, kPas are short for kilopascals. When you see kPa, you automatically assume that is pressure. Then you're going to see mmHg. Those are millimeters of mercury. Millimeters of mercury. Once again, that is automatically pressure. Then lastly, you're going to see TORR. That is an abbreviation for Torricelli's. Once again, that is named after a scientist that contributed to this. Those are torrs. TORR. Torr. Torrs and millimeters of mercury are actually the same thing. They're just different names for each other. So 1 torr is also equivalent to 1 millimeter of mercury. We'll talk about conversions later on. So you got 4 different units of pressure that are the most common. Every time you see ATMs, kPas, millimeters of mercury, mmHg, or torrs, always remember that is pressure. If you don't remember that, the rest of your problems are going to be very difficult to understand. If you understand this, you're off to a great start. So once again, these are my units of pressure. Then volume, always, unless the problem says to solve differently, volumes is always in liters. So the unit of volume is always in liters. Now you'll remember that we learned how to convert. Sometimes your problems are going to give you the volume unit as milliliters or centimeters cubed. You don't want to do that. You want to go ahead and convert it to liters automatically. You always do your conversions right off the bat. There's a problem in an example that I have for you that is going to involve that. I'll show you and I'll remind you really quickly how to do that. But volume is always in liters. So in your gas cell problems, when you see liters, you're always going to think, oh, that's volume, automatically. Then T for temperature is always going to be in kelvins. We learned about the 3 temperature scales already. In a gas cell science class setting, in a laboratory setting, you're always going to use K for kelvins. Always convert to kelvins. Some problems you'll notice will have it in degrees Celsius. And just as a reminder, in order to convert from Celsius to Kelvin, you're going to add 273. So Kelvin is Celsius plus 273. Keep that in your mind once again. So you have Kelvin equals Celsius plus 273. These are my units that are used for pressure, volume, and temperature. Again, you might want to write these down, take a screenshot, a picture, doesn't really matter. Just make sure you're familiar with these 3. Be familiar with your formula. Now I have 2 examples up here. These are from your worksheets, the packet that has this paper in front. I got number 13 and number 5 in case you want to follow along. By the way, you're going to see some other problems where you're like, what is that talking about? If it doesn't look familiar or mention something other than pressure, volume, and temperature, you're probably dealing with 2 other formulas we're going to learn about. So don't worry about those yet. You're going to focus on the ones that either have Boyle's, Charles, or combined gas law at the top. That is your homework. Those are the worksheets that you're going to be doing for the next couple of days. Boyle's, Charles, and combined gas law. that is deviations of the same formula. So those are safe to do already after this lesson. So when I'm looking at the problem, the first thing I want to do is I want to determine which formula am I using. In this instance, I already know I'm going to use both times my combined gas law, which is pressure 1, volume 1, temperature 2, pressure 2, volume 2, temperature 1. Once again, it's important to remember which formula I am using. You're not using the correct formula, you're not going to get the right answer. So once again, go ahead and focus on which formula am I going to use at the beginning. So for number 13, if you go ahead and flip your page over to number 13, you're going to realize the problem's there. I'm not going to write the entire problem out. I am going to read it in order for us to understand how I got here. So the problem says air in a closed cylinder is heated from 25 degrees Celsius to 36 degrees Celsius. If the initial pressure is 3.80 atmospheres, what is the final pressure? Now it seems like a tricky word problem. You say, I don't know what's going on. It's very simple. You're only looking for pressure, volume, and temperature. The other words, do not worry about them. So let's pick out some of these. It says, is heated from 25 degrees Celsius to 36 degrees Celsius. So you actually have two temperatures right there, which would probably be your temperature 1 and your temperature 2. Now, the first thing I have to remember is rewrite my formula. Now, what I did here at the top is I wrote out my formula, the entire one. But if you notice, if you're looking at number 13, that volume is not mentioned at all. Now, the reason why volume is not mentioned is the volume does not change on both sides of the problem. So basically, volume 1 equals volume 2. If that's the case and you put it into your formula, they cancel each other out. So technically, there is no reason why you would include volume at all. So I've actually rewritten my formula right underneath it, excluding volume. It's still the same formula. I just took out volume. V1 and V2 are no longer there. Now it's just pressure 1, temperature 2 equals pressure 2, temperature 1. I've excluded volume because it's not mentioned in my problem, and more than likely, it's the same on both sides. We'll talk about what that means later on, but that's just so you understand why the formula was rewritten. So with that being said, I'm just looking for two pressures and two temperatures. I've actually seen my two temperatures already. You got 25 degrees Celsius and 36 degrees Celsius. Remember, I have to use my unit of Kelvin for temperature, so that means I have to convert them before anything else. So what you have up here is me converting from 25 degrees Celsius to 298 Kelvin, and then 36 degrees Celsius to 309 Kelvin. These are where I got both of these numbers. Now, it's always safe to assume that the first pressure, the first volume, the first temperature mentioned is always P1, V1, T1. It's not going to tell you this is the first volume, but the first one mentioned, or this is the first temperature, or this is the first pressure. The first one mentioned is 25 degrees Celsius, so automatically assume that's temperature 1. 36 degrees Celsius is the second one mentioned, so that's temperature 2. Now, I need to know that in order for me to place it correctly in my formula. What you're doing is you're replacing the letters with the numbers given. That's all there is to it when it comes to these gas laws. So if you notice here, I've converted my temperatures to the correct scale, and I'm going to replace it here. Remember, pressure 1, this is my first pressure. See it right there. If the initial pressure, initial, by the way, is another name or synonymous to first, so that automatically tells you 3.80 is my first pressure. So P1 is 3.80. Now, also, I'm not going to write in my units because as you'll notice, the units cancel each other out, and that takes up space, and it's work you don't have to do. So if I were to put pressure, for example, the unit of pressure here is atmospheres, and I want to put it on this side, the atmospheres cancels each other out anyway, so there's no reason to put those in. So 3.8 is my atmosphere, that's my pressure 1, and then remember temperature 2 goes first. Temperature 2 goes first. My second temperature, remember, is 309. So I'm going to put 3.80 and 309. Pressure 1, temperature 2. Then my equal sign right there. The problem says, what is the final pressure? So I am determining what am I solving for. That's actually the thing you need to notice right after what formula am I using. Next thing is, what am I solving for? What am I solving for? So if you notice right there, it says, what is the final pressure? automatically final pressure is pressure 2 because there's only 2. 1 and 2, final would be 2. So therefore, I'm solving for P2. So I'm just going to leave that right there because it's what I'm solving for. Pressure 2, and then temperature 1 goes right here next to it. Temperature 1 is 298. I've already converted that. So I have my 4 components. Pressure 1, temperature 2, pressure 2, temperature 1, excuse me. Temperature 1 goes right here. Remember that they're switched. Pressure 1, temperature 2, pressure 2, temperature 1. Follow the same order. This is why I'm telling you, you gotta rewrite your formula every single time. Doesn't matter how confident or how used to you get to these problems, always write out your formula at the beginning so you can easily compare it. This is this, this is this, this is this. I'm doing it correctly. So once again, write it in the same exact order. You're always gonna have one variable that you're missing. In this instance, it's pressure 2. From here on, it's just simple math, simple multiplication and division. So since I want to solve for pressure 2, that means I got to isolate it. I got to leave it by itself. It's like solving for x. If you want to replace this for x, because that's how you learn how to do it in a math class, algebra, that's perfectly fine. So I want to leave this by itself. So in order to do so, I need to divide it by this. So what I've done here is I've divided this side by 298 in order to cancel out my 298 on this side. What I do to one side, I have to do to the other side. By the way, I've already multiplied 3.80 times 309. That's going to give me 1,174.20. By the way, when we're working with gas laws, just like you're probably used to already, since you've heard me say this so many times, I always want to limit my numbers to 2 decimal places. Always 2 decimal places, because if you have 3, 4, 5, and everyone in the class has a different amount, then you're never going to get the accurate answer, the one that I want, the one that everyone can agree on. So in order to avoid, what if my answer is this? What if my answer is that? What if my answer is this? Just limit it to 2 decimal places, even your answer, and we're always going to get the most accurate answer. And we're always going to obviously agree on one answer. So I'm going to divide my 1174.20, which is what I multiplied here, by 298 because I want to leave P2 by itself. When I've multiplied, then I'm going to divide this divided by this. I'm going to end up with 3.94 atmospheres. I want to remember at the end, what am I solving for? Once again, I'm solving for pressure. Pressure is atmospheres because I know that's one of my units. How do I know it's supposed to be atmospheres and not one of the other ones? Because I've read in my problem. My first pressure is 3.8 atmospheres. So my atmospheres stays the same. Pressure 2 is always in atmospheres. So this is my answer when it comes to pressure 2. If you want to plug this in up here, into my formula up here, then put it right here. Then they're supposed to equal each other or be close enough. Obviously, depending on the decimal, it might be a little bit off, but this side needs to be equal to this side. And that is essentially how you use the combined gas law in order to solve for these. I'm gonna show you a second example here in the second video. But I want you to realize what my formula is when you're working with Boyle's, Charles, Gay-Lussac's, or combined gas law. It's safe to use the longer version, and then you can just cross out what it might be that you don't need. Once again, P1 V1 T2 equals P2 V2 T1. Remember that formula and know which one's where and where to place it. Know the units for pressure, volume, and temperature. If you understand these 2 concepts, the problems will become